Lesson 3.15, evaluating trig functions using the unit circle. So you should be able to fill this whole thing out. Let's first do the degrees. So we know that this is 0, and then we know this is a 30, a 45, a 60, a 90. 90 plus 30 would be 120. And then this is actually a difference of 15, because this is right in the middle between these two. So this is 135. Plus 15 more would be 150, because 150 plus this is a 30 here would make our 180. 180 plus 30, there's 210. Plus 15 would be 225. Plus 15 is 240, because now we're 60 degrees past the 180. Then we have our 270. 270 plus 30, we have our 300. Plus 15. Plus 15 would be our 330, which puts us 30 degrees away from a 360. Let's go around and do our pi. So now we know that this is 0 pi. We know that 180 is pi. We know that 90 up here is pi over 2, a half a pi. And we know that down here at 270 is 3 halves, 1.5 of pi. Okay, now we've got our 30. 30 is what part of 180? It's a 1/6 of pi. So this is pi over 6. Okay, 45. How many 45s are in 180? Well, 1, 2, 3, 4. It's a 1/4 of pi, so pi over 4. And then 60 is what part of 80? A 6, or 60 out of 180 is a 1/3, so this is pi over 3. So a 1/3 is actually bigger than a 1/6. Then what we need to do is keep going in that pattern. And I'm just going to start here with the thirds. So this was 1/3 is 60. 120 is 2 of those thirds. And then I'm going to jump down here to the 240 because this is 2/3. 180 would be 3/3, which is our whole pi. Then 3/3 plus another third would be 4/3. So 4 pi over 3. And then I have 5/3. 5 pi over 3, because then another third would be 6/3, which is 2 pi. Okay, let's go with 6. This is 1/6. 60 would be 2/6, which reduces to a third. 3/6 here is a half. 4/6, which is 2/3. This would be 5/6, and then 6/6, which is a whole. So now we're going to get improper fractions. 7/6. This is 8/6, which reduces to 4/3. 9/6, which is 3 halves. 10/6, which is 5/3. 11/6. 11 pi over 6, because then this is 12/6, which is 2. And then our 45s, this was 1/4, 2/4, which is a half, 3/4, 4/4, which is our whole, 5/4, 6/4, which is our 3 halves, and then 7/4. Okay. What's kind of cool here is the pattern of, see this pi over 6? If I were to add a whole number, another 6 to it, that's 1/6 plus 6/6, which is 7/6, because you're adding a semicircle to get all the way on the opposite side. That happens every time. This is 1/4, add 4/4, or another whole, that would get you 5/4. So that can kind of help you too figure out what is across from something. Okay, so now let's do our coordinate points. Quadrantal angles are just the ordered pair here. So this is right 1, up or down none. This one up here is 0, 1. At 180, this is -1, 0. And then down here is 0, -1. Okay, then let's go to our 30s. Think of this as dropping down a leg here, and this is our angle. So we need to know, what is this x value? Well, this is the longer leg, this is the shorter. So to get this to this point, we would go square root of 3 over 2. Talked about how that's a bigger value than a half. Okay, then 45 That is my isosceles triangle where both legs, x and y, are square root of 2 over 2. And then at a 60, they're just the opposite of this, because now I have the shorter leg on the x-axis, the y is going to be the longer leg. So I just flip-flop them. And then once you figure out quadrant 1, you can do all the other quadrants. So I'm going to go minor purple. All of these are these 30-degree reference angles. They're all 30 degrees from the x-axis. So I'm going to write those ordered pairs the same. But since I'm going in different quadrants, I know that quadrant 2 goes left, so that's a negative up a half. Quadrant 3, both of them are negative because I'm going left and down. And then this one is right and down. So it needs to be a negative 1/2. Okay, now I'm going to do the 45s the same way of just repeat them in every spot and change the signs. So this should be a negative, positive, negative, negative, positive, negative. And then with my 60s, same thing. All these are 60 degrees from the x-axis, and so they all have the same measurements, but the signs change. And that's everything. And then we know that sine is always the y, cosine is always the x, so this can help you use your unit circle. And then the other thing we need to do is the quadrant. So everything is positive. I'm going to put all in quadrant 1. Quadrant 2, y is still positive, so it would be sine, I'll just cross out negative, sine is positive, and obviously then cosecant is positive. Quadrant 3, both things are negative, x and y, so that means tangent is positive down in quadrant 3, and then quadrant 4 is going to have your x's be positive, x's go with cosine. So all students take classes. That's a way that you can remember the quadrant. And then the last thing you might want to add is tangent. Tangent of 30 is y divided by x. You're taking 1/2 divided by square root of 3 over 2. And so that's going to get square root of 3 over 3. And then a 45 is easy because you're taking the same y divided by the same x, so tangent of 45 is 1. And then tangent of a 60 is the reciprocal of that, which is just radical 3. So you might want to go ahead and fill a tangent out for all of them, and then knowing that these switch, I guess we could do here too. 0 divided by 1, tangent of 0 is 0. Tangent of a 90 up here is 1 divided by 0, that's undefined. So you could label all those. And I just marked them beside each angle. So the way you could use this is, say you're going to find cosine of a 120. So you could literally just go to 120, cosine is x, so that would be negative 1/2. So you want to find tangent of a 300. Find 300 degrees, tangent we've already gotten written is negative square root of 3. So that's how you could go faster. You can even use it with reciprocal functions of knowing that you just turn it around, flip it.